Okay, this is dynamics. Of the three mechanics classes I teach, this is the one that's heaviest in math. Really the only one of the three where you do a lot of calculus and some differential equations and stuff. The differential equations we do, I think differential equations is listed as a co-requisite for this class, but I'll tell you everything you need to know about differential equations, so that doesn't even matter. The only ones we're going to do are separation of variables problems, the sort of the simplest kind. But before, we're going to start, most of this is going to be the syllabus probably today. But before we start that, I want to go meta, So I want to tell you the two things that are, more and more I feel this way, the two things that are going to determine how this class goes. One is sort of a procedural thing, and one is an understanding thing. So the two main keys to this class. The first one is just how you approach this class. I don't think, like as engineering classes go, I don't think any of my classes are especially hard. I mean, engineering classes in general are pretty hard. Sometimes you take some that demand a ton of hours. Mine is not that way. But almost everything about my grading is designed to, like my goal in coming up with a grading approach is to separate the people who are spreading out their time, doing a little bit every day, from the people who are like keep putting it off because they have other stuff to do and then pull an all-nighter the night before the exam. That's no way to learn, and so since I'm sort of signing off on people learning this material when I give the grade, I'm doing my best to design tests and quizzes and homework that reward the people who are doing it a little bit every day. So if you look at the time commitment that's expected for a college class, you can Google that, and 20 different universities' web pages will come up. And one will be Harvard, and one will be Southwestern, whatever, But they're going to give the same answer. And the answer is, for every 1 hour in class, you're expected to put in 2 to 3 hours outside of class. And so just to make the math nice and round, I'm going to be on the low end of that and say 7 hours. Okay, we're in class 3 hours a week. 7 hours a week of work outside of class. That's what I want you to do, and that's 1 hour a day. And in my experience, the people who do 1 hour a day are going to do a lot better than the people who try to do 7 hours on Sunday or whatever, So the first one is 1 hour every day. That's not 1 hour most days. That means on the days that you miss your hour, it's 2 hours the next time. You know what I mean? It's 7 hours a week, each week. Not 7 hours most weeks. If you go on a trip and you get 3 hours in 1 week, then you have to do 11 hours the next week. You know what I mean? And then the second one, so that's just the way you approach this class. And basically, let me say one more thing about that. As exams get close, I always end up with a lot more people in office hours, and not everybody, but some of those people are still trying to figure out how to do problems, the night before an exam. And the mindset is like, okay, well, the exam, when we cover this stuff, that's the deadline for when I have to learn how to do these problems. But that's not how I think about it, you know, and that is not how you should think about it, I don't think. You should think about it like the day that I assign these problems, that's when you have to learn how to do these. And if you can't figure out how to do them, you have to talk to me right then. The rest of the time, from when it's assigned to when the exam happens on it, is just your time to ingrain those good habits, you know. And so these tests, I don't give a lot of, I mean, for dumb math mistakes, I give a lot of wiggle room, but on procedural things, I don't give a lot of wiggle room because you really shouldn't be thinking about these problems anymore at the time you take the exam to a large extent. Your hands should be doing those problems. You should be able to talk on the phone and do those problems, you know what I mean? And not on the phone to someone who's telling you how to do those problems, you know what I mean? And then the second one is an understanding thing, and this has been sort of a revelation to me in the last couple of years. The people who do well in these classes, the people who understand this material well, are the people who understand this simple thing well, and the people who struggle are the people who have trouble with this sort of simple thing. The main skill you need let's say before learning dynamics is giving, or sorry, erase that with your little electric pencil. Calculating coordinates in a given coordinate system and very closely related to that is calculating vector components. We're going to be doing stuff in 2D and 3D. And the first problem, set of problems that I'm going to give you is going to be problems where in 2D and 3D you're just calculating vector components, calculating coordinates. If you're smooth with this, the other concepts seem to come a lot faster. If you're not smooth with this, I've seen a lot of people who feel like they're struggling with dynamics where really they're just having trouble with sort of this stepping stone you need before you can do dynamics. Yep?
Just curious, are we going to need to know anything more about vectors compared to statics?
Anything more? No, it's really the same.
Okay.
The same thing is true of statics. The same set of skills. It's the key to being ready to do statics and the key to being ready to do dynamics. Not so much deform, by the way. But all right. Anyone have any questions about any of that? Well, let's go through the syllabus. Some things have changed. A lot of the people in here, most of the people in here just took statics with me last semester. I've fiddled with a few things. But there's a lot of people I haven't had in class before, so it helps to go through this anyways. Oh, no. I got to be on the internet for this. No. Yeah, exactly. Okay. It's funny when I started, I had this like really early version tablet computer and really basic connectors, and I never had a single problem. And now that after all these advancements, like my tablet's harder to use because it's a touch screen, so I make marks all over it with my hand and like all this stuff. Like I just want to go back to 2007. Okay, so everything that you need in this class is going to be given on D2L. So your first assignment is to get into D2L. If you go to the Normandale main page, there's a tab right at the top right. Enter your star ID and your password. If you don't know that, you just have to go talk to IT and they'll help you with that. You're early if you're taking a class at 11. No offense. All right, so you get into D2L, and you see a main page like this that lists all your classes on the right. I think mine's a little different because I'm an instructor. Go to Dynamics. And this is the main page you see. When I give assignments, it's going to be listed under those announcements. So that's the first thing you see, and it's the first thing you should scan. Is there anything new? When I make updates to problems or whatever, I'll try to remember to put it in there. I'll try to remember to, in class we'll talk about when the tests are coming up and what topics are going to be on, but I'll try to put it on there too. So that's sort of home base. Go to materials and content. That's where everything is. And there are a few categories. Course information has the syllabus, a vector review to read. That's the first assignment is going to be based on that. Some formulas for centroids, mass moments of inertia, some programs that could be useful in dynamics if you have a TI-89, if you have a different graphing calculator, and you want to use these programs and you can't figure out how to translate it, there'll be some differences in syntax. Come talk to me and we can probably figure it out. I don't remember how to do it in every calculator, but we've figured out how to do it in for most graphing calculators. I have it for TI-89 because that's the calculator I have, but and then all the problems are already given, although I think I am going to make a few changes to the later ones. But basically these assignment problems are what you're responsible for this semester. If you understand the way to go through all the problems in these 8 problem sets, you're good. There are solutions posted. Little by little, I'm trying to ferret out the mistakes in the solutions. There were some in statics. I'm embarrassed to say there's more in dynamics. I know there are. I'm trying to get those. It would help a lot. I would really appreciate it if, when you think you see a problem, send me an email. Telling it to my face doesn't help as much because, I suppose I should just write it down somewhere, but I tend to lose that stuff. So an email is more helpful that just says, I think your solution to number 2, part D is wrong or whatever, and then I have something to go on. So I would really appreciate that. Eventually this is going to be perfect, and students are going to be like, I can't believe how good your solutions are. And I'll be like, it was always that way. Yeah, right. And so these are all done, let's just look at some of these solutions. It's all my handwriting, just going through step by step how to do these problems. And just like in statics, ooh, that's an ugly one. Just like in statics, there are not solutions to every problem. There's solutions to the majority of them, but then some of them there's no solution for. I can do some of those in class if you have questions about them, but some you're just going to have to be responsible for.
Do you leave problems out intentionally, or?
I leave them out intentionally, yeah, right. Old lecture notes. So you might have noticed that I'm doing this lecture on a computer. And the nice thing about that is at the end I get a PDF of everything I've written. This is on, right? Yes. And so these are the lectures from a previous semester. I guess you can tell this was last spring. So if you click on one of these, you can see everything I wrote. Pretty great, right? My notes are right there. But wait, there's more. What would you spend for notes like that? $80? $50? No, it's free. And if you take this class now, I'll also give you the link to the YouTube channel where videos are, I'm recording this as video too. So let's go to that previous semester. If you go to my channel, go to playlists. These are all the playlists. Ooh, you should watch my liked videos. People playing guitar and stuff. But for now, so Dynamics Spring of 2016. So if you go to that playlist, there are videos for every class. There might be one or two missing just because technical difficulties or whatever, but and if you go to one of those, skip ahead.
These two are both the same.
You can't hear
They're
the sound
equal
because it's just
to
coming through my computer, but
4
you hear my
radius of
voice
the
as you
circle
watch
over
my
3
lecture.
pi.
So it's really useful if you miss a class. You can
And
watch the
then, of course,
lecture at
the
your own
area of that
pace.
shape is
And
equal to
even
pi
if you
r
miss a
squared
class,
over 4.
you can print out the PDF and then take just notes in the margins as you watch the lecture video. And also, if something just went by too fast and you can't make sense out of it just from the notes, you could go
and
back
then
and
a right triangle.
maybe watching the video again will help. So I will, after class today, I'll make the new YouTube channel for this semester's videos, and I'll put a link on D2L so you know where that
So let's
playlist is.
say this distance
Let's
is
see what this
B,
notification is. I hope it's not someone saying they hate my lectures.
and this is H.
Okay. Oh, that's just doubled. I don't know why I have 2 there. I'll fix that. These are all doubled. I'll get that out of there. So that's the layout of D2L. For now, what we want is the syllabus. Anybody have any questions about the layout of D2L for this class? Okay. So here's the syllabus. There's contact information at the top. You can get a hold of me by phone, but email works better. My office is S2302. That's also the last 4 digits of my cell phone. So you only have to figure out 6 other digits to call me on my cell phone. So what's that? 1 in 1 million chance with a million carefully chosen attempts, you could find my cell phone number.
We can narrow it down because it's probably
That's true. It's
612 or something.
yeah, exactly. Yeah, good thinking. You could narrow it way down. Yeah,
So actually it'd be more like,
it's 612, so 1 in 1,000, let's say.
yeah,
Okay.
man, that sounds like a good try.
Yeah. You could split it up and like you take the 0 to, I probably won't answer though. If you find it and call me. I probably won't. That's true. Office hours are right after class Monday and Wednesday for an hour. And then Tuesday and Thursday for an hour from 10 to 11. If you can't make it to office hours, send me an email and I'd be happy to set up a time outside of those hours that we can meet that works for you. In the fall, I do a lot of my office hours in the lab where it's sort of study hall format. I really like that format, but it doesn't work with my hours in the spring, so we're just doing regular ones in my. Although, now that I think about it, I think I might look into doing my office hours in the tutoring center. I think that's an option. So I'll get back to you if I change that. But for now, it's just in my office. Prerequisites are Physics 1, Calc 2. Like I said, the co-requisite, it says, is differential equations, but we have the prerequisites and co-requisites just listed to match up with the U of Minnesota. You'd be fine without differential equations, although Calc 2 is pretty important in this class. Any questions about that sort of basic course information? Course objectives. I won't talk about that. Materials. You need a good calculator. We're going to be solving a lot of big systems of equations that you don't want to be doing by substitution. So you need a calculator where you can enter matrices and solve using reduced row echelon form. It's easy to do on a calculator, but you don't want to do it with a little solar punch, you know what I mean? Yep.
I assume we can use like MATLAB or something.
Oh, yeah, sure. What?
We can use MATLAB?
MATLAB would be great. Yeah, that would be better. On tests, I'm trying to think what.
Could be the honor system.
MATLAB honor system. On homework, for sure, MATLAB. On tests, let me think about that.
Well, I didn't have a calculator.
Okay, yeah. So MATLAB is great. I mean, use that as much. The more familiar you get with MATLAB, the better off you'll be later on. I'm all for that. And then the textbook, this is sort of, well, this is how I do all my classes, but unusual for people who haven't had my classes before. There's no textbook for this class. I would recommend getting a textbook as a reference for later on. Any of the, right now, the current versions are Beer, Johnson, and Cornwell, Vector Mechanics for Engineers. It's the textbook they use at the U. It didn't used to be Cornwell, so if you can find Beer and Johnson Dynamics book, it's the same thing, just an earlier edition. I would get an older edition. The newer editions cost a lot of money. The older ones you can get on eBay or Amazon a lot cheaper. I would do that. And then really, to me, even better than that textbook is the Shams outline, and that's what I say about any science class, engineering class you take from now on. Get the Shams outline for it. It's cheap, $15 or $20, and it has 1 million problems with some full solutions, some answers without the solutions. So it's just a great way, like if you're trying to refresh your memory for a standardized test, professional engineer's exam or that kind of thing. It's perfect for that. And it gives very brief little synopses of all the subjects. It's not as wordy as a textbook, which can make it a little harder to learn from than a textbook. But if you've already had the stuff, a lot of times that concise description is better, It's sort of what you're looking for. One other thing about the textbook. Deform and statics, the way I teach those deviates quite a bit from the way textbooks generally teach those topics. That's sort of good and bad. Dynamics, the way I teach it, is a lot closer to the way it is in the textbook. So if you wanted to look in a textbook for a second, second opinion on, the reasoning or whatever behind any of these approaches, in this class, that'd be a reasonable thing to do. I wouldn't do that in statics or statics or deform for the most part. And then there's the topics. The grading scale looks a little high. The cutoffs are 94, 84, 74, 64. I have never really understood why so many engineering classes have such low curves. You know, to me, as an engineer, there's nothing more important than having a clear distinction in your mind between what you know and what you don't know. You know, like if you're supposed to do something for some research project later, or the company you're working for, and you expect your boss to be happy about you getting 72% of it right, you're in for disappointment. You know what I mean? So yeah, basically, like, I'm trying to present things in a clear, simple way. I'm trying to make you ingrain those habits, and basically put these tools in your toolbox, and I want you to get it all right, kind of. That's sort of how I think about it. The grade breakdown: 70% exams, 20% assignments, 10% quizzes. So for the people in statics, the quizzes are a little lower in the mix than they were last semester. That's the only change. So now let me talk individually about exams, assignments, and quizzes. The exams, there are 5 of them. 70 divided by 5 is 14% for each one, so there's no exam that's worth like a ton of points. That includes the final. The final is just sort of another exam. And each one of those exams is cumulative up to that point in the class, so you need to keep refreshing your memory. Largely, I'm going to require you to go back and redo old assignments. And this semester, I'm actually going to have you turn in problems that you've already turned in. I'm going to try that, see how that goes. You definitely, no question, should do every problem in this class a minimum of twice, you know. And the second time you do it, you should be able to think through it pretty smoothly without, you know, and without looking at the solutions and that kind of thing. If you can't, then you definitely need to do it again. Yep.
Just out of curiosity, is this going to be like statics where the topics kind of stack on each other anyways?
Not as much.
Okay.
Statics is more that way than just about any class in the world.
Okay.
Dynamics, it's kind of more moving from topic to topic. That will happen a bit, but not as much. And then my makeup policy on exams. In extreme cases, I mean, it can't hurt to talk to me before the exam if you can't make it. Maybe we can work out a makeup or something, but for the most part, I don't give makeup exams. If you miss an exam, you get a 0 on it, except then for the last exam, exam 5, if that score on your last exam is higher than any of your first 4, and if one of your first 4 is a 0, that's obviously going to be the case, then that exam 5 score counts as exam 5, and it also counts as the lowest of your first 4. You know what I mean? So like if you got 80, 80, 80, 20, and then 90 on your 5th exam, that 90 counts as your 5th exam, and it also replaces the 20 for your 4th exam. Okay, so with that system, you can miss one exam, and it doesn't affect your grade because then your exam 5 just fills in for that 0 later on. Okay. The dates of all the exams are right there, so check your schedule and make sure those work. The final schedule is already available. I didn't look up the date, but we can figure that out as soon as you want it. And so the times of all of the exams are already determined. The second most heavily weighted category is assignments. You're going to turn in assignments every 2 weeks. I'm going to list the assignments in the announcements on D2L. Each day I'm going to give an assignment. So it'll say the assignment for Monday, whatever today's date is. It's like October or something right now. January. So it'll list today's date and say these problems are today's assignment, and it'll say Monday, January 9th, and then in parentheses it'll say due whatever 2 weeks from. I'll have to look, but so it should be pretty easy to follow what assignments are due in each 2-week block. I want these assignments to be done neatly. I think that's an important part of developing towards being an engineer who works in a professional environment. And so I expect them to be paper clipped or stapled. I expect them to be the problems to be in the order that they were assigned. So don't have number 4 after number 8 or whatever. I want them in the order that I assigned them. And particularly, I want you to put some care into the figures that you draw, the free body diagrams and any drawings you do of what's going on. To me, straight edge, I don't care about that, but I just want you to put some care into it. It shouldn't look like a scribble. I should be able to tell what directions the vectors are pointing that you're drawing. Okay, that kind of thing. If you have any questions about, bring me an example and I'll tell you I like it, or else what things I would like you to change if you have doubts about what I'm talking about. So these assignments are going to be graded, and so there's always this kind of tension between the desire to have students work together and then the need to be able to grade students' work individually. To me, this is the distinction. This is like where I draw the line between what kind of work I want you to do together and what I want you to do by yourselves. I'd like you to work together as much as you want, as much as possible. It's a great habit to get into, to understand how to do these problems. But when it's time to write up the paper that you're turning in to me, you should be able to write that up without referencing the notes that you took when you were working with other people. Okay? So yeah, work with other people to gain an understanding, but that understanding has to entirely be contained inside your head before you write it out. You know what I mean? If you took notes when you're working together with someone and then you're writing up your final paper and you have to keep looking like, wait, now you divide by 4? Now I see. Then like you never really got the understanding of how to do it. So that's the distinction to me. What you turn into me needs to represent your understanding of the material. Okay. Late assignments. I want to make a special note of this. In statics, it was sort of like turn it in as you see fit. You know what I mean? Whenever you want. I just can't, logistically, I just can't do that this semester. I have 4 separate classes. So if you can't get an assignment in on time, come talk to me before it's due and we can decide when you're going to turn it in. But I'm going to have to be more, buckle down on that more than I did last semester. Okay. Because I just need to know when I'm going to have time to grade all these assignments without having to come back later and grade a bunch more of the same thing. Any questions so far? I haven't asked for feedback really yet on exams or homework. Yep.
So the assignments will be posted online.
Yes. I showed you where all the problems are.
Yeah.
So on the announcements in D2L, I'll just tell you which numbers from which set is for that day. Okay. So the problems are already there, and I'll just on D2L tell you which ones to do for today, Quizzes. Every 2 weeks there'll be a quiz where there'll be 2 things on these quizzes. They'll be asking for you to remember things I said in class, and as we go on in the class, I'll give you an example of what kind of things you might want to look for. But basically that means that you are going to need to read your notes back and keep skimming over your notes to remind yourself what I said. And then there'll also be, it'll ask you to reproduce problems that you've done in the assignments. So just nothing new, stuff you've already done if you've been doing the assignments, but asking you to reproduce that. These quizzes are cumulative, so it's not just in the last 2 weeks, it's everything up to that point. So when you skim your notes, you should be skimming back over all of them. But again, I'm going to try really hard in my assignments to make you do and redo things on a schedule that'll make this easy. I mean, everything about my goal for this class is to make you spend 16 weeks just constantly refreshing this material that I think is important to take away with you when this class is over. And there's a quiz schedule there. So every Friday, every other Friday, those are the dates. There are no makeup quizzes. There are 7 quizzes there. They make up 10% of your grade, so less than 2% per quiz. So just don't miss many of those, you know. Missing none is ideal. But I will drop the lowest score. So if you miss one, that 0 gets dropped. And then I don't have issues with cheating in my engineering classes much. The way that would most likely occur is like copying on an exam or something. We have a ton of space in this room anyways. So please don't put us in that situation, but that's what I'll do if it happens. It happens more often in my college physics classes than engineering classes. Any questions about that? Okay, so that's the syllabus. Well, let's stop. So I'm going to give you an assignment today that is just reading through that vector review, and I think especially for the people who just took statics last semester, it's the same vector review. You might want to skim it quickly, but basically, you know, there's not going to be anything new in there. And then there are 15 or so vector problems, including determining the coordinates in given coordinate systems in 2D and 3D, and figuring out the vector that points from this point to this point. That's the stuff that I said is the main skill that's going to determine how ready you are to learn dynamics material, in my experience. If you have trouble, so you're not going to, just to reiterate, you're not going to turn that assignment in on Wednesday, even though it says it's today's assignment. You'll turn it in 2 weeks or whatever when I say you're going to turn in this big chunk of stuff. But if you have any questions about how to do those problems, we can talk about it on Wednesday. Okay? All right. See ya.